LiDAR data is becoming very popular and very common. It is well suited for road design. The only limitation is that there is a large number of points that are sometimes difficult to process and can overrun your computer as well as your software. I'm going to show you some strategies today on how to import and process this data a lot easier and also design on top of it. There's the X and Y accuracy and the Z accuracy. It's quite expensive to acquire a LiDAR. Here's some of the points that I'll be hitting on is raw data versus grid data, all points versus bald earth, ASCII versus binary. What you want from your data provider, data delivery provider, is to ask him or her for a raw data file and not the grid data. The reason is that some of the foliage that is prominent in a raw data file is not prominent in a grid data file. It's hidden, as you can see down here on this point. You also want your LiDAR provider to send you the bald earth if you plan on doing any kind of earthwork design. You don't want to have this person send you all points because then you're going to have to take a long time to extract the points that you need. ASCII versus binary. I'm going to show you how to import both of these. We can import binary files now, LAS and LAZ files. I'm going to focus after I've imported the LAS files and showed you how to do a tin on them and some other stuff. I'm going to import an ASCII file. ASCII file is the most common that you'll find still out there because the provider usually provides the ASCII file to their clients. This is what a typical ASCII file looks like. Easting, northing, elevation. Files will usually, from your provider, files will usually come in rectangular tiles. What you want your provider to do is to limit the file size. You don't want more than 10 million points per tile. The road that I'm going to be designing today is around 9.5 kilometers long. And the file has about 3.3 million points. RoadEng can read in this data, although there are some strategies that you should be aware of with RoadEng. First strategy is to preview at low resolution and design on low resolution file, and then swap it for a higher resolution file after you're done your initial design work, your preliminary design work. You should also orient yourself with images. Trim the data is another strategy. I'll show you how to do that in RoadEng. We can do that quite easily now. You can create a corridor around a feature, which will bring in higher resolution data around within that corridor and lower resolution data outside of that corridor. Like I said below, you should design with low resolution and generate your output and do your full design with full resolution files. Swap out the low resolution with the full resolution files. Strategy number 4 is you should try to not display your points. That will save on memory and on storage space. Don't create one feature for every single point. Try to create one feature for a number of points, and I'll show you how to do that. Don't put in any kind of labels for your points. As you can see down here, that can take up a lot of memory. Strategy number 5 is get more memory or a faster computer. Here's a quick summary of all the strategies. I won't go through them. As you can see, they're all there. First thing I'm going to do is I'm going to show you how to import a binary file, an LAS file, or an LAZ file. Choose my import format, go File, Open. Choose my import format, which is LAS files. Format LAZ. Choose my file, which is points.laz. I'm going to import all points. This is not a very big file. It's only got 1,327,917 points. I'm just going to import them all. We can handle 4 or 5 million points quite easily. So just be aware of this. You can see also that I did not display those points, but they are there. If I select, there they all are. If I select all on my screen, Control A, see that they're all there. I'm going to deselect them by clicking on blank space. Next step is to generate my tin. Press the Generate Tin button. You'll get the terrain calculation dialog box. Since this is a rectangular box tile with the data in it, I can freely include all triangles. If it was a file that had meandering points all over the place, I might not want to include all triangles. I might want to limit the maximum side length of triangles. I'm just going to calculate minor contours. 5-foot interval, I think, would be good enough. Start my minor contours at 700 foot. Go to elevation 1600. Press OK. Doesn't take that long to calculate your contours, especially with only 1,400,000 points. It's quite quick. There's my contour file. Show you what that looks like in 3D. There you go. It's quite hilly. Before I go on to my ASCII data set, I'm going to show you how to create a profile across one peak to the other. Tile these two vertically, my plan and my 3D window. Edit, new feature, name it a profile, turn on model, then turn off elevations because I just want it to drape across the surface. I'm going to go from one peak to the next. Left click once, you're presented with a pencil. Left click once. Left click again to tie it down. Move to the other side of your, the other range, the other peak. Left click once. Left click again to tie it down. Let's take a look at a profile of this. New window, graphics, profile. There you go. Move this over. Let's move this point somewhere else. Pick it up. You'll see how it redraws quite quickly. Move that point over here. It will redraw instantaneously right across that surface. Move on to importing ASCII files and doing a road design on top of that ASCII file. Let me just show you the end result of what my data set will look like once I've imported the file and done my tin model. I'm going to show you what the low resolution file looks like, and then I'll go through the process of creating the high resolution file. So this is the low resolution ASCII file. You can see that there's already an alignment there. I'm going to use that alignment to create a corridor when I import the data. First thing I'm going to do is open up my alignment. You can see that the name of the alignment is called just simply alignment. Down here on the lower right. Now let's import the ASCII file. File insert. So once you've opened up one file, the next file you have to insert. Choose the file format that you want to insert. ASCII LiDAR. My northing is in the second column. My easting is in the first column. My elevation is in the third column. And if you go to your code tab, you can see that I'm not displaying these points like one of those strategies that I told you before. You should not display your points to save on memory and storage space. One of the strategies was also to group your points into one feature. So basically I've got 1,000, a little bit over 1,024 points per feature. Next step is to create my corridor, add my feature that I'm going to create a corridor around. Select this feature called alignment. I'm going to create a 200-foot corridor around, or 200-meter corridor around that alignment.